A 5-meter thin long rod has a mass of 10 kilograms. It's supported by a fulcrum at the center. On the right side of the fulcrum, a force of 8 newtons is applied 2 meters from the center. On the left side of the fulcrum, a force is 4 newtons applied at the edge of the rod. Find the net torque on the rod. So we have this rod. Here's our fulcrum, right? We have a force of 8 newtons, 2 meters away going down. And then we have a force over here of 4 newtons. And since the rod's 5 meters long and it's at the edge, this is at 2.5 meters. So the net torque, since both these objects are pushing in opposite directions, the net torque is going to be 2 times 8 minus 2.5 times 4. All right, so the net torque is 16 minus 10, or 6 Newton meters. So the first answer is 6. Find the moment of inertia. So I equals the mass of the rod, which is 10, times its length squared divided by 12. So 10 times 25 divided by 12 is 20.83 Newton meters. So this is 20.83 Newton meters. And we already found the net torque, so I'm just going to write that down one more time. All right, this was 6 Newton meters. This is not Newton meters, I'm sorry, this is kilogram meters squared. To find the angular acceleration, so the net torque is I alpha. So 6 equals 20.83 alpha. So alpha, 6 divided by 20.83 is 0.288 meters, or radians per second squared. So how fast is rotating if the net torque is applied for 25 seconds? So omega equals omega naught plus alpha t. Omega equals 0. And then we know alpha, we just solved for it, is 0.288 times 0.25. So 0.288 times 0.25. 0.072 rads per second. 2, a 5 kilogram solid disc, 1 meter, has a moment of inertia of 0.875 kilogram meters per squared and is sliding on a frictionless surface. The disc leaves a frictionless surface and comes across the surface with a coefficient of static friction of 0.45. What does the force of friction produce? So the first thing is, let's just solve for FF. So FF is mu mg. So 22.05 newtons. How much torque does this produce? Well, as the ball is sliding to the right, there's no torque because it's just sliding, and then it hits this like barrier. Here there's friction, here there's no force of friction. So once it hits here, now, since friction is going to push this way, it's going to start to cause this to rotate. And now, since it's causing it to rotate, it's going to apply a torque. So to find out how much torque this is going to apply, torque equals force, 22.05, times radius. It happens to be 1 meter away from the center. So we get 22.05 Newton meters. What is the angular acceleration of the disc? Well, 22.05, that's our torque, equals I, and the I was given to us this time, 0.875 times alpha. So divided by 0.875, we get 25.2 meters or radians per second squared. 25.2 rads per second squared. If the disc rotates with this acceleration, how long would it take to complete 10 full rotations? All right, so theta is 10 rotations, but we can't use rotations. We have to multiply it by 2 pi. So theta equals 10 times 6.28, or it needs to travel 62.8 radians. We're trying to find out how long that takes. So we can use theta equals theta naught plus omega naught t plus 1/2 a alpha t squared. This is always 0, and since it wasn't rotating before, it was sliding but not rotating, there's also no initial angular speed. So we can just solve theta, which we know is 62.8, equals 1/2 alpha 25.2 times time squared. We solve t. 62.8 divided by 25.2 divided by 1/2, and then take the square root. It would take 2.2 seconds.